In this episode, we're going to go over the use of torque wrenches. This is a standard automotive torque wrench, and you'll notice that this is from 5 to 80 foot-pounds. So we don't ever use torque wrenches with foot-pounds in the central office. We always use inch-pounds. You'll also notice that this actually has Newton meters on the other side, so you need to pay attention to what your drawing says. If you're using the Newton meter scale, you're going to use this. If you're using the foot-pounds, you'll use this side. So in order to set this wrench up, many of your insulated torque wrenches are similar design to this. It has a locking mechanism at the bottom. Put this to 0, set that up at the lowest setting, which this particular one, oops, I'm on Newton meters. Oh, this is foot-pounds. So we're going to go up, let's say we want to go to 12. We'll go, there's 10 right there. At the 0 right on the line, and then count over. There's 1 and 2. Set that up, lock it, and now you're ready to use it. Just use it like any other ratchet, tighten it up, and you'll feel a little bit of a little pop in the wrench, and that'll tell you that it's reached the torque. It won't go any more beyond that. And when you're done, unlock it, bring it back down to its lowest setting, lock it back in place. That just removes the tension from the spring. This is our standard Telecom double insulated torque wrench. This one has a little bit different locking mechanism, and you also notice that it says inch-pounds. And it also has a Newton meter scale on the other side. This particular wrench is from 30 to 150 inch-pounds. In order to set this, you pull down the locking mechanism. Let's say we want to go up to 32 inch-pounds. There's the scale, 0, 1, and then 2. Just slightly over 30. And when it gets to the right setting, this will pop up in place and lock. Put your cover back on and go ahead and torque it. It'll give you the same sort of little pop when it gets to the desired setting. One thing to keep in mind is when you torque anything, it has a torque value and then there's a retorque value. You don't ever retorque something to the same setting. You always torque at a lower value. So once you've torqued it, that's why you need to mark it and be done with it. So then we're going to go to, this is a double insulated torque screwdriver. Many of our central office equipment requires torque settings below 30 inch-pounds, and almost all of our torque wrenches go to 30 inch-pounds. This particular torque screwdriver goes from 6 inch-pounds up to 30 inch-pounds, or actually it goes to 36 inch-pounds. In order to set this one, you just pull it down. So right now we're at 0. If we wanted to go up to, let's say, 8, so we go 6. We're starting at 6, so there's 7, 8, and that's it. And it'll lock back in place, and you just tighten it. And please, once it gets to the desired torque, this one just keeps turning. If I can get enough tension off to do it. See, it just stops turning once it gets to the desired torque. And these have removable heads. You could put this is a spur socket. You could put, Phillips head, standard head. There's all kinds of different fittings that they just screw into these, and that's it. Now that we've completed the review of how to use the torque wrench, let's talk about where you get that information so you know what the torque settings are. This that we're looking at right now is TP 76300, section K. We're going to look at paragraph 4.8.6. Now this is for 1/4 inch 20 connection studs or 5/16 18 connection studs. It's mainly for the rear of the BDFB. So the torque requirements for the 1/4 20 connections is 72 inch-pounds. The torque requirements for 5/16 18 connections is 132 inch-pounds. Now this is a general rule, but the manufacturer requirements always override this. So then we're going to go over to, this is an excerpt from ATTP 05100E, which is for the return bus bar hardware. And you'll notice this is note 13, you'll notice it's talking about bolts and nuts. For this, quarter 20 is 80 inch-pounds, and 5/16, 18 is 180 inch-pounds. So now let's go look at some different interconnect drawings. Now this is a excerpt from a fuse panel drawing. This would have been referenced within your spec. And so we'll go to this particular figure, and we'll notice that for this we're going to use, for the quarter 20 studs, you're going to use 36 inch-pounds, which is half of what they're allowing on the posts at the rear of the BDFB. So if we use that criteria that's in the TP, we would snap off the studs. A lot of that has to do with the type of metal that they're using. But this is for the input side of this particular fuse panel. And you'll notice on this one, it doesn't give us a torque setting for the frame ground. So you might have to actually refer to the manufacturer or ask the detail engineer for that information. So then we're going to go, this is the output, and this is pretty straightforward, quarter 20. It's also 36 inch-pounds. So that one's pretty straightforward. Then we get to this ADC PowerWorks fuse panel, and it gets a little more complicated. Here for our inputs, the A and the B, those are quarter 20s, and the max torque for those is 32 inch-pounds. And then on these 8/32 screw type posts, those are only 15 inch-pounds. And then when you get to the 6/32 screw type connections, those are at 12 inch-pounds. Now this fuse panel has a lot of torque information in it. For our chassis ground, it's 32 inch-pounds plus or minus 2. And then our inputs, both A and B, those are at 50 inch-pounds plus or minus 1. And then we go over to these are our outputs. This is both the load and the return. These are quarter 20, and they're at 32 inch-pounds. And then the GMT positions down on the bottom, those are at 15 inch-pounds plus or minus 1. So now we're going to look at a CRS 8-slot drawing. This is the interconnect drawing for the 8-slot. This is for the shelf itself. It's not for a fuse panel. Now this particular equipment does go to a fuse panel. As you can see up here, ATTE 01151W-01. So you're going to have a torque requirements up there, but down at the equipment, these are also quarter-inch studs, but these are only 20 inch-pounds. So it's a lot less than what you were using on the fuse panel, which was also a lot less than what you're using at the BDFB. Now our chassis ground for this is actually at 30 inch-pounds. And that was in the figure for the power connection. Now for the Juniper MX960, I've taken note 1 right out of the drawing, and that's where it contains the torque information right in the notes. And for this particular one, it's 23 inch-pounds, and it also gives us the Newton meters, 2.6 Newton meter, and 25 inch-pound or 2.8 Newton meter. So you get a lot of different information. Some drawings are going to give you the inch-pounds and Newton meter. Some are just going to give you the Newton meter. Some are just going to give you inch-pounds. So you really have to dig around a little bit. Now this is right out of an Emerson BDFB drawing, the manufacturer's drawing, and their information lines up perfectly with what's in the TP. For the TLS TPS fuse holders, it's 72 inch-pounds. For the TPL fuse holder, it's 132 inch-pounds. So that one works perfectly with the TP. Then we go to the Lucent BDFB, and we look at the cartridge type fuse block, frame ground, and internal return bus. On those quarter-inch studs, we're looking at 75 inch-pound. So there's a little bit of variation, and it's really important that you look at the manufacturer's information. So I hope this has helped you identify different places you can find that information. If you can't locate it within the drawings, please contact your detail engineer or your local quality advisor for assistance. Thank you.